All right, this is topic 3, friction. We're going to break this up into 2 parts. The first part is really vocab and kind of understanding the definitions. So here we go. Friction is the ever-present resistance to motion that occurs whenever two materials can be anything from surfaces to atmosphere, okay? When two materials are in contact with each other. Friction is a force. We use the lowercase f or script f with the vector symbol above it. It opposes motion, so it's going to go the opposite direction that you are applying a force or that the object is moving. And it is always parallel to or with the surface. There are 3 things that affect friction. The first thing is the materials, so the materials that are in contact. The second is the mass, and the third is the acceleration. We're going to focus on the 3 things that affect and then eventually come up with an equation for friction. Okay? So let's start off with the materials. When we talk about materials, we're going to use this Greek letter. It's the Greek letter for M, lowercase m, and it's me in Greek is how you pronounce that. And so this is going to represent the materials that are involved. Now this is known as the coefficient or coef of friction. All right. The coefficient of friction is basically it's a percentage that is written in decimal form. So if the 2 materials that are in contact have a really high coefficient of friction, that means that the 2 materials are getting kind of stuck on each other. If the materials have a low coefficient of friction, then the materials are easily gliding past one another. So let's take a look at those 2 scenarios. The first scenario that I mentioned was if it's a high coefficient of friction. So for this picture, we're going to take a box. We're going to put the box, so just a box. We're going to put the box on a bunch of grass, real thick grass that needs to be mowed, that hasn't been mowed yet. So a lot of stuff, kind of material that's in the way. Okay, so this is grass. Now grass is rough. There's a lot of grooves. And I say grooves because that allows material to bond. No, not bond as in forever, but bond enough to make it harder to give a resistance to the motion of the box. And that's what friction is. It's a resistance force. So in this particular case, we would have a large coefficient of friction. So the material is big, or the material is a rough material. So it's harder for the box to move on this material. So our coefficient of friction would be high. The next scenario is when I have a low coefficient of friction. So we're taking the same box, but this time we're going to put it on a sheet of ice. Ice is smoother. assuming it's been Zambonied. There's very few grooves. So the box and the ice are not going to bond as easily. This is the case of a very low coefficient of friction. Obviously, the box will move easier on ice, which means the resistance force or friction isn't as big. Now, the coefficient of friction is usually known. We have a list of coefficients of frictions, which you guys can kind of see some of those in Schoology. That list is posted for you. But it can be anywhere from 0.01 to 1.8, which is a relatively large friction, coefficient of friction. But the materials affect the magnitude of friction, so how hard or how big friction is working. The next two, I'm going to actually combine the next two. So the three things that affect, we just talked about material, and I introduced you to this Greek letter M, or me, for the coefficient of friction. Next, I want to look at the mass and the acceleration. The mass and the acceleration. Obviously, if the box is large, it's going to be harder to push. It's going to have more surface touching another surface, so that would increase the coefficient of, or I'm sorry, that would increase the friction. If I move my object at a high acceleration, that will minimize the friction. Okay, so if I can get the object to move quickly, so speed, maybe we want to use the word speed instead of acceleration, but where does this come from in the picture? So here we have a surface, a box on a surface, right? And this box is going to be 30 kilograms. And then the next picture, we have a box that's 5 kilograms. So what increases and what decreases here is the weight, and if it's on a flat surface, we're talking weight and normal force. So it's actually, because it has to do with the surface and the contact here, friction, and I'm not really concerned about the weight of the box as much as I am with the normal force. So the normal force is high here, and the normal force is lower in this particular case. So because mass and acceleration have to do with friction, how much the force is going to be acting against my motion. So if I want to push on an object, obviously it's going to be easier to push this object, so the friction is going to be relatively low compared to this object. So we have those three things that affect friction: your materials, and your mass and acceleration. And so I'm going to put those together in a nice little formula. Okay? Friction can be found by taking the material coefficient of friction times the normal force. And so that is how we can calculate friction.